Welcome to Keentel Engineering. 12 essential parameters define how a large generator performs, protects itself, and stays compliant with the grid. This is a complete technical guide covering MVA and MW ratings, excitation, cooling, short circuit ratio, and overfluxing protection for utility, industrial, and renewable power applications. Modern steam turbine generators exceed 1,700 megavolt amperes. Let's get into it. Generator ratings define continuous operating capability, thermal limits, mechanical stress limits, insulation capability, reactive power capability, grid support performance, stability characteristics, and protection coordination requirements. As ratings climb above 1,700 megavolt amperes, operating margins tighten, making accurate engineering analysis critical. Misinterpreting these parameters can cause rotor overheating, stator insulation failure, core damage, synchronization failures, grid instability, generator trips, reduced asset life, and catastrophic failures. Modern generators reach above 1,700 megavolt amperes in steam turbine applications and up to 400 to 500 megavolt amperes in gas turbine systems. Apparent power, measured in megavolt amperes, drives generator size based on the voltage and current product, not real power alone. It impacts bus duct sizing, generator step-up transformer sizing, breaker interrupting capacity, cooling design, and relay settings. Real power, measured in megawatts, equals megavolt amperes times power factor. Megawatt overload is serious. It generally signals stator current overload, risking winding overheating and insulation degradation. Power factor for large turbo generators typically runs 0.85 to 0.90 lagging. Overexcited operation supplies reactive power and supports voltage. Underexcited operation absorbs reactive power and reduces voltage. Keentel performs reactive capability studies, voltage stability analysis, and ERCOT and WECC interconnection support for inverter-based resource-heavy grids. Terminal voltage typically runs 13.8 to 27 kilovolts with continuous tolerance of plus or minus 5% per IEEE standards. Synchronization requires matched voltage, frequency, and phase angle. Errors cause shaft torque, pole slipping, and transformer damage. Stator current capability is cooling dependent. Air-cooled gives the lowest rating, hydrogen-cooled improves capability, water-cooled gives the highest. High current drives copper losses and insulation stress. Field voltage controls, rotor excitation, an automatic voltage regulator, malfunction risks overexcitation and loss of synchronism. Field current drives rotor flux, increased field current raises MVAR export and terminal voltage potential, monitored for overexcitation, loss of excitation, and pole slipping. Synchronous speed follows 120 times frequency divided by pole count. At 60 Hz, 2 pole machines run 3,600 revolutions per minute and 4 pole machines run 1,800 revolutions per minute. At 50 Hz, 2 pole runs 3,000 revolutions per minute and 4 pole runs 1,500 revolutions per minute. Higher speeds increase centrifugal stress and tighten balancing tolerances. Hydrogen pressure up to 75 pounds per square inch gauge improves heat transfer, reduces windage losses, and increases MVA capability, but requires careful leak and seal oil monitoring since mishandling presents an explosion hazard. Hydrogen temperature typically runs 30 to 40 degrees Celsius cold gas with a 46 degree maximum and a 15 to 25 degree differential. Poor cooling causes rotor overheating and stator insulation damage, monitored via RTDs and thermocouples. Short circuit ratio for modern turbine generators typically runs 0.4 to 0.6, the ratio of field current for rated open circuit voltage to field current for rated sustained short circuit current. Higher SCR means better voltage regulation and improved transient stability, but a bigger, less efficient, costlier machine. Low SCR systems are increasingly common with inverter-based resources, requiring weak grid analysis and PSCADEMT simulations. Volts-per-Hertz, or overfluxing, is among the most dangerous abnormal operating conditions for generators and transformers. Flux density is proportional to voltage over frequency. Overfluxing causes core saturation and severe heating that can destroy core and winding insulation within seconds. Typical causes include AVR malfunction, load rejection, and underfrequency. Protection relies on ANSI 24 overexcitation relays and flux monitoring. Generator capability curves define operating boundaries imposed by stator heating, rotor heating, core heating, and stability limits, critical for dispatch optimization, voltage support, and renewable integration. Keentel's generator services span 4 areas: generator studies, load flow, short circuit, dynamic stability, harmonic, and EMT analysis. Generator protection, relay coordination, differential, out-of-step, overexcitation, and loss of field. Design support, interconnection, excitation systems, synchronization, cooling review, and grounding. Renewable integration, weak grid analysis, IBR compliance, NERC modeling, PSCAD, and ERCOT and WECC compliance. What's the difference between megawatts and megavolt amperes? Megawatts is real usable power. Megavolt amperes is total apparent power including reactive power. Why are generators rated in megavolt amperes, not megawatts? Heating depends primarily on voltage and current, not real power output alone. What causes generator overheating? Excessive stator current, overexcitation, cooling failure, poor hydrogen pressure, and high volts-per-Hertz operation. What is reactive power in generators? MVAR supports voltage regulation and system stability but performs no real work. What does overexcited operation mean? The generator is supplying reactive power to the grid. What does underexcited operation mean? The generator is absorbing reactive power from the grid. Why is hydrogen used for cooling large generators? Excellent thermal conductivity and low density reduce losses and improve cooling. What is generator synchronization? It ensures voltage magnitude, frequency, and phase angle match the grid before breaker closure. What is a capability curve? It defines the safe operating limits of a generator in megawatts and megavars space. What is short circuit ratio? It measures generator stability and excitation sensitivity characteristics. Why is low SCR a concern? Low SCR systems are weaker and more susceptible to voltage instability and oscillations. What is Volts-per-Hertz protection? It prevents excessive magnetic flux that can damage generator cores and windings. What happens during overfluxing? Core saturation occurs, producing excessive heating and insulation stress. What is the purpose of an AVR? The automatic voltage regulator controls generator excitation and terminal voltage. What protection relays are commonly used for generators? Differential, loss of field, overexcitation, reverse power, and negative sequence. Why is stator current critical? Excessive stator current directly causes copper losses and winding overheating. How does frequency affect generator speed? Synchronous speed is directly proportional to system frequency. What is unity power factor? Voltage and current are perfectly aligned. Zero reactive power exchange. Why are hydrogen temperatures monitored? To ensure proper generator cooling and prevent insulation damage. How does Keentel Engineering support generator projects? Power system studies, generator protection design, dynamic modeling, renewable integration analysis, NERC compliance support, and interconnection engineering. So here's the bottom line on generator ratings. 12 parameters, from MVA and MW to power factor, cooling, short circuit ratio, and volts per hertz, define the real operating limits of every large generator on the grid. Get them wrong, and you're looking at overheating, insulation failure, or a protection trip you didn't see coming. Get them right, and you've got a machine that performs safely for decades. As generators push past 1700 megavolt amps and grids lean harder on inverter-based resources, understanding these ratings isn't optional anymore. It's core engineering. If you're specifying protecting or interconnecting utility-scale generation, Keentel Engineering can help, from load flow and short circuit studies to relay coordination and grid compliance. Reach out at keentelengineering.com or call 813-389-7871. Thanks for watching, and I'll see you in the next one.